The phase change notes are kind of fill in the blank. On here you're going to notice two things. One, in red I put the right answers in on the line, so you can just kind of follow along with those. And I also put some strike throughs for anything that you don't really need to worry about that's on the notes. So I'm just going to kind of talk you through them real quick. One, a phase change is any physical change in state of matter. So solid to liquid, liquid to gas, solid to gas, gas to liquid, however that may work. All phase changes involve something related to temperature and energy. So that's really what our focus is going to be, not so much on the naming of the phase changes, but on the temperature and energy. So in all phase changes, energy is transferred. You have two possibilities. You can either absorb energy or release energy. In an endothermic reaction, endo means in, so it absorbs energy. So what you're going to have is going from something that's more ordered, like a solid, to something that's less ordered, like a liquid or a gas. In order to do that, the molecules need to absorb energy to speed up, and that's why that's taking in energy. Exothermic releases, exo is exit, releases energy. So this is something like freezing. You're going from a liquid that's a little bit more moving around, moving of molecules, to a solid that's not as much moving around. So you're releasing energy to slow those molecules down. So down here in melting and freezing, in melting, like we just said, it becomes less ordered as you go from solid to liquid, and in freezing it becomes more ordered. So looking at melting, ice gains energy and the molecules move faster. At the melting point, some molecules gain enough energy to move past each other, so they start sliding around each other. Once all the molecules have that energy, then melting is complete. The key for that is that the next part here, during this time, temperature does not change. Even though the molecules are moving around more, the temperature does not change. Once all melting is complete, then the temperature will start to increase as you're gaining more energy. Freezing is the opposite. You're going to lose energy. The molecules are going to slow down. As they start to slow down, they start to attract each other, and then as they attract each other, they start to form the more structured solid. Again, during this time period, temperature does not change, and once all freezing is complete, then the temperature will start to decrease. Vaporization is any liquid to a gas. It's an endothermic process. You have to take in energy to go from a liquid, which is a little bit more structured, to a gas, which is definitely a lot less structured. Down here I kind of struck through all this part, but basically evaporation takes place at the surface. Boiling takes place throughout, and that's the only difference between them, but they're both vaporization. Condensation is the opposite of vaporization. It goes from a gas to a liquid. It's exothermic because you have to give energy off to slow down the molecules to go from a gas to a liquid. In sublimation, you're going from a solid to a gas. It's endothermic. Again, solids are very ordered, gases are not, so you have to take in energy to become less ordered. Example of this is dry ice that we played with in the lab. Deposition is the opposite, going from a gas to a solid. It's exothermic. We're really not going to worry about an example of that because it usually takes places at low temperatures and low pressures that we really don't need to worry about. Here's just in chart form everything that you need to know here. All the terms, endo or exothermic, so whether it's gaining heat or losing heat, and then notice in the temperature change column, it's none all the way through. Down here, this is a phase change diagram, and below it, I kind of wrote this all out in paragraph form, so you can kind of read through it if you would like. As we go through here, I'm just going to scroll up. I'll try and get it all in one here. As we go from point A to B, that's a solid. The temperature is rising. Once we get to point B, that's the melting point. And from point B to C, we have what's called the heat of fusion, or the energy needed to go from a solid to a liquid. Temperature does not change, but there you are adding heat. Once you get to point C, everything is a liquid now, and from point C to D, we are liquid that's gaining energy and gaining temperature. Once we get to point D, which is a boiling point, we are going to start to gain energy again without a temperature change. This is called the heat of vaporization. Once we get to point E, we've vaporized all our liquid molecules, then we become a gas, and from that point on, the temperature can increase. If you have any questions, make sure that you ask me when you get in class.